Greetings, welcome back all. I wanted to, the next thing we're going to do is we're going to dig a little bit deeper into networking and then storage. So this section is going to go by fairly quickly because we really want to get you guys to the important stuff, and that is building your own lab. So we'll get to that in short order. In this session, I'm going to start us off with talking about secure isolated virtual networks, bring your own IP address, hybrid cross-premise networking, as well as site-to-site VPN, and then Brian's going to talk a little bit about point-to-site VPNs as well. Starting off with Windows Azure Virtual Network, a couple of things to note about it is the networks. Whenever you set up a network, you can set up secure isolated networks for different machines. So you're not limited to just everything you dump into Azure being on the same network. You just like Hyper-V, you can have multiple networks, and then you can have different machines tied to those different networks. They are secure. They are isolated virtual networks running in Windows Azure. You can bring your own IP addresses. Your internal IPv4 address space has persistency. So if you have a couple servers in your infrastructure, you want to dump them all into Azure, just port them, move them. Go for it. Do it. Super simple. As you expand or extend your network, and when we get into the hybrid scenarios, you can very easily set up to have your on-prem network connect directly to your cloud infrastructure network to securely extend your enterprise networks right into Windows Azure. There's an on-ramp for migrating apps and services to Windows Azure, and the way that it's designed, it's really designed for you to very easily be able to have your on-prem and your cloud infrastructure communicate as one. And we'll show you a little bit about that as we talk about site-to-site VPNs. But also it's important to note that from a point-to-site VPN or a client to site, direct connect VPN functionality is available as well. So let me show you real quick. Let me switch over to my machine and take a quick peek at what's up with the site-to-site VPN. Now there's a good white paper on how to set up the site-to-site VPN, and I've got a shortcut link which I'll put in the window in a couple of minutes. I think it's ak.ms/azvpn. So Keith, maybe if Keith or Brian, if one of you guys could just confirm that that's the correct link, and then it'll take you to this create a virtual network for site-to-site cross-premise connectivity, which should be displayed shortly. And from here, you can really learn a lot about the site-to-site for cross-premise connectivity. So this gives you all the instructions, including step-by-step, on how to link your on-prem to your Windows Azure infrastructure, and you can do that both from a site-to-site connectivity standpoint as well as from a client-to-site VPN connection. It literally is as easy as going in and creating the networks. Now, whenever you're doing site-to-site, you want to have authentication being done via certificates. And right now, whenever you're doing your certificate, you do want to have you can create that certificate in your organization. So you're creating a local certificate. You're not, you don't have to go out and create a public certificate for that. You're basically just going in and you're creating a local certificate on your network, and then you're telling Azure to trust that network, and vice versa. So that's how the connectivity works. There are some particular components, some requirements for the terminating device on your on-prem network. And so you can look at the white paper or the compatibility list for what's available from a compatibility standpoint for your different devices that you can connect to. But of course, you can connect to a Windows Server machine as well. So you can go in addition to your site-to-site direct connectivity, which you can do via a device like a gateway, like a firewall. You can also go direct directly and connect to a VPN and enable routing. So there's lots of different ways that you can establish that VPN connection. And you'll see here that there's from a compatibility standpoint, there's different options available to you. Now, if I scroll all the way to the top of this particular website, there is a configure a point to site VPN in the management portal. Literally, you're just going to go to that connection, and it will give you the step-by-step on how to do this as well. But more about that in a few minutes. Let me switch back over to the deck.
And we're seeing your PowerPoint now.
Okay, awesome. Don't know how I got to this slide because I selected the wrong one. Sorry, guys. I grabbed the wrong slide deck. Yeah, one thing that you'll find on the compatibility list is some of the lower end boxes are not going to have that, not going to have the capability. They're not going to be on that compatibility list. But again, whenever you get into that scenario where you don't have one of the higher end devices that has that compatibility, you certainly do have the capability of being able to connect a server to a server from the VPN standpoint. So you can certainly do your connectivity in that way. And so let's go ahead and go to take a look at the hybrid cross-premise network for remote users and see what that looks like. So the hybrid cross-premise scenario is where you have your on-prem network, where maybe you have, that's where you have your System Center, your SQL, your web servers, Active Directory, DNS, Exchange, whatever your internal infrastructure is, including all of your clients. Well, if you have a site-to-site IPsec VPN tunnel from your site to your cloud network, where you might be hosting other things, whether it be file and print services, AD, SQL, SharePoint, whatever, then you're just going to have two different. It's going to be treated much like a branch office is, where you might have an IP address on space 10.1 for your on-prem and an IP address space of 10.2 on your cloud network, and that gives you your full hybrid cross-premise connectivity. So any machine on your cloud network can communicate to your on-prem network and vice versa in this scenario. And then if you have clients, this is your point-to-site VPN users for remote users. You can also have them connect to your VPN gateway. So in your site-to-site, you have a VPN gateway on both sides, on both your on-prem and your and on your cloud. And for the point-to-site VPN users, you have those users connecting to your VPN gateway on your cloud network. Now there are limitations on the number of users that you can have connected to the remote to a remote VPN gateway. I think it's 250 concurrent remote client connections are supported, and on your on-prem VPN gateway, it must support dynamic routing. So that's one of the primary things that's going to stop you from some of your lower end boxes of being able to support your site-to-site connectivity. But in the scenario where your point-to-site VPN for your remote users, they might have a local IP address of 10.3 or whatever, they're still going to be able to have that connectivity through that point-to-site VPN for remote users. So, Brian, you want to take it away and kind of tell us a little bit about? Oh, actually, no. I'm gonna talk a little bit about. Yeah, actually, Brian, go ahead and take it away. You want to talk about the building that out?
Sure. Let me just share out my desktop here. All right. Now, as soon as you're able to see that, what you'll see is I'm back into the Windows Azure Management Portal. We'll wait for a little bit for that to come up. Okay. So in Windows Azure Management Portal, I'm going to click on the left side onto networks. And as we can see, I have 3 networks here. And one of the things that you get used to after a while inside a web browser management tool, I don't know if we mentioned that this is all HTML5 based. It works in any of the newest browsers, so we don't need any special plugins or anything like that. But when I select different ones, if I select towards the right side, that will select my network or my virtual machine, etc. But if I select on the name here, where this arrow is, or even over on this section here, it takes me in that piece, and I've just gone into the BGL net, which is a network I have set up. In that network, if we go to my dashboard, what we'll see is not only the stats about my network, how much data has gone in and out, we'll see the servers that are that were built, the virtual machine servers that are built on that network, as well as their IP addresses. And then another piece off to the right here is download the 64-bit client package or the 32-bit client package. When I install that, what that does is it installs the VPN client for me. And so on my Windows 8 box here, if I swipe in from the right, I basically go to Settings and Network. You can see my list here. And so BGLNet, the same network we're working in Azure, is listed here. If I click Connect on that, it will connect up that VPN to that subnet. So basically, this is how I can get in to manage, in this case, these 3 servers, and I'll hit the 172 address directly then from my machine, and I would rConsole directly to that instead of going in and starting it from the management portal where we're our remote desktoping in over the internet. Here we would do all our management through that VPN. Now, the way I had to set this up to get stuff to happen in the first place is the first thing I have to do is go to this Certificates tab, and I have to have a certificate. Now, I created my own with a tool called MakeCert.exe, a small little executable that I downloaded off the internet. It's part of the SDK, the Windows SDK from Microsoft. We have directions on how to do that on different blogs, and certainly we can get you links to that. Another way to do it in a more productive production-type environment would be to go purchase a cert from VeriSign, Entrust, those different companies. And then once we upload our root cert and have our client cert installed to the local machine, that's how it gets the trust to happen in that VPN. We don't use a password here. When I initiate that VPN, it just uses that certificate to do that connection. So the first thing I have to do is put that certificate up in there. And then the second thing I do is I create a gateway. And so it sets up this network where I have a gateway address and a gateway subnet, and it basically hooks my subnet up. So back to my dashboard here, if I were to connect that VPN, it would have my data in and my data out, as well as how many clients are connected through that VPN, and I would access these directly. So that, to me, is a really nice situation to set up. Back when we were first doing Azure, I had created I was creating a lab environment, and I spun up some virtual machines. And in those VMs, I set a password as capital P, ASS W0RD, and then I might have put an exclamation point, I don't recall. It was a standard lab password for Microsoft Labs. And so I was working in that VM for about 5 minutes when all of a sudden I was logged out because the administrator had logged in. Well, I had just provisioned that machine. I was the administrator. So someone had used a hacker tool, most likely TS Grinder, that had gone and searched through all those IP addresses over port 3389 because I didn't have a random high port. I was using port 3389 on that virtual machine. I was using the user ID administrator with a password that was basically almost password. So a rather insecure, bad way to do it. It took them 5 minutes to find me and basically take over my machine from me. I immediately logged back in as myself and took the control away from them. And then I drew a blank on how to change a password. I couldn't remember. I started a command prompt, and the actual command would be net space user space administrator space the new password, I believe is the proper command now. But they knew it. I didn't. They logged me back out and changed my password on me. I had to close that VM and start all over from scratch. So certainly the things that we've done from an Azure standpoint of getting rid of the administrator as the standard user name, making you use difficult passwords and not simple passwords like password, have protected us from those types of attacks, as well as not doing port 3389, but doing some random high port. So those things definitely protect us, but if you want to make sure it's guaranteed rock solid, this is how to do that. We set it up with a point-to-site VPN, and then you manage them directly to their local IP address, like the 172.16.1.4 here for this server. So that is my point-to-site VPN and how to configure it. When you do create it, you create a gateway is the next last step. When you have that, it basically generates packages at that point in time. These packages for downloading are not listed on the right side until you have everything configured, because then it generates them on the fly. When you hit download, it builds it with the IP address and that information that you need, and then you can start to download. So when I hit download, it doesn't download immediately. It actually creates it every time I hit the download link uniquely for me. Okay. So we'll go back to the deck. And this really comes to the end of what we were talking about for the networking piece. Certainly, we talked about using your own network, your own secure isolated networks, and really extending your data center or your network into a remote data center, basically into our data center. Some of the things that are unique there are things such as the IP address on these servers. If my server has an IP address of 10.0.0.1 and I change it to 10.0.0.2 and I have other servers that are .3 and that kind of stuff, it won't be able to communicate. The only address it's able to communicate is that 10.0.0.1. It can get it by DHCP, or it can get it by hard-coding it in there. It's going to originally get it by DHCP. I can change it to hard-coded in, but I cannot change it to any other address. Basically, it is verifying on that virtual switch, that port and that IP address. It has to be that IP address. So that's kind of a protection scenario. So you can't make changes and have communication go like you would on your own piece of hardware. So that's one thing to pay attention to, is that the IP address you're given for that server is the IP address that you're given for that server. No other IP address will function correctly for that internal IP. But it allows us to set up that environment and basically have our network scaled out onto another environment. Even if you aren't doing a site-to-site VPN or a mesh network where you're extending your corporate network, it's still a nice idea to set up a network so that when I build my servers, they're on the same local segment, and I can have them talk to each other locally on that virtual segment, as well as then I can create that point-to-site VPN there. Now, if I do create a site-to-site VPN or an MPLS network, I still have other ways to access. So if I did a site-to-site VPN, I can still create a point-to-site VPN on that same network. And so it's part of the corporate network, but it's also something I can, from my desktop, directly VPN into. So some of the cool stuff in Azure Virtual Networks. Last piece now before we get our hands dirty, which is we're going to talk about Windows Azure Storage. Now, Windows Azure Storage is our persistent cloud storage. It's really ridiculously inexpensive, as Dan had pointed out before. At 9.5 cents per gigabyte is the most expensive that it gets. And as far as storing your data up there, if there's things for backup that you have, if you're using Microsoft Data Protection Manager, you can just have it make another copy up in Azure Storage. That's kind of a checkbox setting, and then put in your credentials, and so you can have a backup that way. I know vendors such as Seagate have been looking at adding that if it's not already in there. They did have it in beta for a while, a couple of months ago, that it would pop that up in Azure Storage. I'll talk more in a little bit about backup to Azure Storage that we have built into Azure for Windows servers. But it's really nice in the sense that if I'm using a backup agent into Azure Storage or something, it's really, really inexpensive as far as a storage area to add as a backup environment. Now, if we look at the disks and how we do it, I mentioned before, and Dan mentioned before, that we have geographical redundant storage as well as we have locally redundant storage. And so the way our storage works is, this is persistent storage, and I'm going to take a copy and put it on 3 disks. The way we do our data centers, we saw that video of our data centers, but it's really unique. We don't use SANs in our data center. We build our own SAN, basically, using Windows Server. It's a feature that you can do in Windows Server 2012 as well, using local attached disk and using the new storage spaces that we have in there. And you can really build some amazing throughput for locally attached, inexpensive disk. I have a customer who's basically built up an environment similar to his $125,000 SAN, and he's built that up for $25,000. So it's a very similar environment. It doesn't have the company that shows up and helps tweak it and some of that, but it is $100,000 less, and it gives the same size and throughput, which is really a pretty nice, impressive way to go. What we're doing is all commodity-based hardware, and it's all commodity-based disk. So one of the things that's interesting there to me is, a question that often comes up is, well, what about security of my data? Right? What happens when that drive goes bad, or what happens when a container eventually gets switched out? I didn't know the answer, so I asked the guys at the data centers, and they actually have a standard process. They don't go into those shipping containers, the Gen 4 containers. They don't go into those very often, but when they're returning one of those containers, they go into them at that point. They pull all the drives. A drive never leaves an Azure data center or a Microsoft data center, at least not alive. What they do is they use something similar to a wood chipper. It's a hard drive shredder, and if you haven't had a chance to see one in action, at some point YouTube that, because it's really interesting to see a drive dropped into a slide and just get broken into small strips of metal. And that's what we do for all data destruction, all drive destruction when we remove drives from Windows Azure. Anyway, by default, what we have is we're storing that data on its mirrored blocks onto 3 disks. So those 3 disks are in different channels, so that if one of those bays were to go bad, we still have they're not in the same bay, so that you won't lose the whole bay. Another thing we've learned is disks from the same pallet often go bad at the same time. So if you've bought a pallet from a production of disks, it's strange how when one starts to fail, the majority of the batch starts to fail within the same 30-day window when they're built. So we do know to multi-source disk and to do that with our drives. And so basically, what if I do miss a drive fails on me, that drive goes bad. That's fine. What we'll do is that drive's marked offline and bad, and we just rebuild that. We have 2 copies left, and we just rebuild that 3rd copy right away and spin up a 3rd copy, and you have 3 copies of your data again. And that's at a site. We always have 3 copies, 3 mirrored copies of that storage. We don't do tape backup, though, so it is important for us to have those 3 copies. So we will always keep those 3 copies. Now, by default, when you create things, we're going to actually have geo-replicated storage. And so we have that at 2 data centers. And so we have 3 copies at one data center and 3 copies at another for a total of 6 copies. And it doesn't really cost a whole lot more to do that. The standard charge, right, goes from 7 cents per gigabyte for local redundant storage to 9.5 cents per gigabyte for geographically located storage. And so the other thing is the data centers are more than 400 miles apart. What is the reason for that? The reason is, and the idea behind it is, if there's a calamity, if there's some type of catastrophe that comes and hits a city, whether it's a natural disaster or some other disaster, we don't want that taking out both data centers at the same time. And so therefore we have them over 400 miles apart, and that's how we store your data for geo-replication. Now, one of the things to do pay attention is if you do start your storage as a locally redundant storage, and then turn on geographical storage, you will be charged for the bandwidth as that replicates. But if you don't, if it's by default on from the day you start it, then you don't get that charge. So let's go look real quick at provisioning some storage. and what that takes. You will be doing this in just a few minutes. And the guide will help walk you through that, but this is something that we will have you do shortly. Dan, anything you want to add while we wait for this to load up? All right, we're up. All right, so back to our favorite portal, which is the Windows Azure Management Portal, and I'm going to go into storage, which is about halfway down in the list. We see that I already have a bunch of storage environments. If I click New and create another storage environment, I just give it a new name. It checks it. It turns green if it's not taken already, so this name is unique, so I can use that. And then I choose where I want to place that storage. Also, I have the checkbox if it's enabled for geographical replication. Now, I can choose to go into my affinity group if I want, or I can choose to go into one of these other sites, West US, East US, or some of the other areas around the world. One of the important things is when I create a storage container and I'm going to run virtual machines, they have to be in the same spot. If I create a storage container in the Western US and then want to create my virtual machines in the Eastern US, I won't be able to put it into that storage because it's not going to run very well if you're trying to map your storage across the WAN links from the east to the west coast. So you do want to make sure that you have your storage and your VMs. The admin interface won't let you create it across those boundaries, but you do want to make sure you understand that if I'm going to create a VM in North Europe, I need to create my storage in North Europe, my network has to be in North Europe, and my VM then goes in that same spot. The way we make that easy is by using what's called an affinity group, and when we create it into an affinity group, it automatically places it where all the other things that we're placing in that affinity group goes. So then I just hit create storage account, and that's all I need to do for my storage account. So that one is creating right now. In thinking about timing and how long it takes to switch between slides and back, I'm going to go into my next demo for storage here right away. And what I'm going to show is basically use storage spaces. And so one of the tools that I use, I can certainly use the admin space here. So for example, here's my live storage space. I grabbed that short name, I think, before anyone else thought of it. So I was able to grab that. No one else can get live. This was a library I was using I set up a lab and had people copy stuff from my Azure storage, which you can do. All you have to do is go and make it visible to the public, and then people, besides yourself, can copy files out of there. And I was basically building virtual machines, VHD files, and allowing other people to copy them out of my account and into their account. The nice thing is if you're copying a 40 gig file out of my storage account in Azure in the same data center, let's say the Eastern US to your Eastern US storage account, 40 gigabytes was copied in about 10 seconds, which was pretty interesting, pretty amazing. We do use InfiniBand network cards, which are 56 gigabyte per second, theoretical limits. We do have some pretty neat data centers and design set up. But as I go into this library here, I'm going to click on the last tab, which is called Containers. And as I click into the containers, what that shows me is it shows me my folders. And so if we look at this URL here, http live.core.windows VHDs, that is an accessible URL as well. If I open it up and allow people access to it, they can get to the files in there. So this is something I can use to have data that customers may want to download. If I want to put videos up there, if I want to put other large files up there for people to pull down, I can use this environment for that, this storage. Right here we see that I have 3 VHD files up there right now. I have one that I named servereval.vhd. This is the one that I uploaded last night as I tested the lab. It's a virtual hard disk. And if I wanted to get it, one of the things I could do is unlock it, and then using this URL, http live.blob.core.windows.net, /VHD/server VHD, that into a web address will allow that to be downloaded, right? And so I can get to any of these that way. Now, by default, you can't. No one but someone who has rights to can see that. Again, I can go in there and I can edit that and change that and open that up for read so that others can get it without any authentication and be able to pull that down. So this is one way to look at it, and it's from the admin interface. Another way to look at it is using the API set. And if we use the API set, I'm going to pull up a free tool that does that called Cloudberry Explorer. So Cloudberry Explorer is a tool that's just like a Windows File Manager type tool. And as we see, here's my local hard drive. Here's the a temp directory off my C. So I've just got files. Well, it does the same thing over here. And I've got different Azure storage environments that I can go into. And I can either go into their folder, or in those, many of them I have a VHD file. The one we were just looking at is the Azure Lib. And so I had a folder called VHDs, and in there I had those 3 VMs, and here they are. So another way I could grab those, if I want to download those, I could just drag it, drop it, and then I could copy it down. Or if I wanted to upload, I could use this tool to drag and drop and upload files as well. To add your environments to this, you just go to the Azure Blob Storage account, and you add an Azure Blob Storage account. You give it whatever name you want. You give it your Azure name. In this case, I'll do the one we looked at, which is Lib. And then I need a shared key. Well, you get the shared key from the, you can either use PowerShell, or I could go here and get it, which if I go to my dashboard, this is where I get my shared key. And the shared key is something that, as I show you, that's my key right there. Let's go get this key. So that key there is the key that is the key to my kingdom as far as this storage account is concerned. So if I have that unique key, paste it, and I can't. All right, let's do that again. Oh, I hit regenerate, not copy, huh? All right, let's go. No, that's not what's going on. One last time we'll try this. There we go. So I can test the connection. The connection was successful. That means that's good, and I can say OK. And now I have this added. So if I go to this list of my different Azure accounts, that was the whatever account. And here again, we have those same files in the list. And so not only can I get to it from tools such as this, which is just using the open API, you can build your own tools. There's some open source tools that we have put up on Codeplex. There are things you can do with the PowerShell commands as well, and the PowerShell commands can access this from a command line perspective as well. So if you want to script things, we will use those PowerShell commands in the lab to manage our environment here as well. But so just to let you know that you can access the different storage areas in different ways. All right, now back to the PowerPoint.
So, Brian, while this is loading, my apologies if I couldn't hit the unmute button fast enough earlier. But do you talk about pricing and the fact that upload versus download pricing deltas? My understanding is the upload cost is that no charge for the storage?
So the upload. So when you're doing upload, that's for network costs, and the upload, anything going into Azure is free. It's only things coming out of Azure. In the Azure environment that costs money. And from the charge perspective, it's really inexpensive, 3 cents per gigabyte type things. If we go, I'll demo my environment again and show what my charges are. And as you'll see, as you look at the different pricing, things, for the most part, in storage and network are pretty inexpensive. The things that really cost money are the virtual machines, the hourly use charges on there. And so you can go see a detail of your bill as you go along. And again, I think it makes sense for us to show that. But you can see exactly what we're using. And you'll see that it's maybe $3, $4 a month in storage and bandwidth, where I'm using, $50 or sometimes I've used up my $150 that I get in my MSDN account. I have MSDN Ultimate, so that gives you $150 a month free of Azure. And I have done where I provisioned a lot of servers and some big ones, and I've used up my $150 before, at which point I have a choice. I can either remove the spending limit, because it does have my credit card number. I can remove that, and then it can start to charge me as we go. Or I can leave that, and it will basically disable the account until the next month, and then enable that. Now, if you guys set up trial accounts today, that trial account will come pre-filled with $200 that you'll be able to use for any of these services. And then after 30 days, it will basically, if you don't enable and lift the spending cap and let the credit card be billed, it will basically just disable that account. And then they will clean out your data that's there at some point later. So
yeah, one other thing on that is that also applies to downloading from Windows Azure, right? Like, so we're going to be downloading a VHD from the web and stuff?
Yeah, any traffic that we do in Azure is traffic that things into Azure is all free, and things out of Azure is where it gets charged, but it's still a relatively low charge. So the stuff that we're downloading, we're going to basically remote control a VM and download a 4 gigabyte file today. That's all free because it's coming into Azure. Now, if you were to push that out of Azure and download it to your environment, that costs money. That's why I think Azure Storage is such a great thing for backups. Anything you push up there is free. You don't pay. You pay for the storage, right? How many gigs per month you're storing up there at 9.5 cents a gig. But it's not until you download that you actually end up paying any network costs. And so if you don't have a need to download, if you don't lose your data, then you never pay any network charge. You purely pay storage charges. Because everything uploaded, no matter how much a month you do, you could upload 50 gig a month, and you still pay $0 for that upload. Make sense?
Awesome, thanks.
I imagine that was a softball for me, so thank you, Dan. Okay, so what we're looking at now on this slide is accessing the blob storage. We talked about that the URL, HTTPS, the account name that you've given it, blob storage, is how you access it from a string. But we didn't talk about what these things are. So first we have the account, then we have the container or the folder. Then lastly we have the file. There's different types of files here. There's one called a page blob, and one called a block blob. So when I have a block blob, that would be things for like movies. So blocks are the ones down here. And the blocks, as you see in the right side, are 4 meg blocks. The blocks are the largest file size you can have as far as a block blob is 200 gigabytes. And what these are for is these are for videos. So, I can pick up right in the middle of a video, and that video then can start to play right from that middle. It'll basically skip chunks forward 4 meg at a pop and then pick up it where you want it to. So that's the idea on the video files. And, the 200 gig is a pretty large video, so that's the limit we have there. Now, if we move up to the VHD size, those are using our page blobs. Now, a page blob has a max size of 1 terabyte. So the largest VHD and the largest disk that you can have in Azure is 1 terabyte. Now, this is differentiated by the largest file size that you can have of a VHD file on-prem is 2 terabytes. So that's one of the things you want to watch for is if you do a 2 terabyte drive, that will never be able to upload to Azure, right? There's a difference. And right now in Azure, we don't support VHDX files. We only support VHD in Azure. The speed changes that we've done there, the enhancements we've done, is something that we would definitely like to have in Azure. But the 64 terabyte size increase, that's not something that's going to help us because we're still stuck because of the back-end storage at 1 terabyte max size. So we've got a lot of different storage scenarios. So some of the people we work with look at moving everything up into the cloud. And that's really great, except that you have certain situations where it doesn't make sense. So we've got other things to try to help that. One of those things is Store Simple. It's an appliance. It's basically a server that you put on-prem that caches your Azure storage. And so I can have servers hit that using iSCSI and store their VHD files, which then get backed up to the cloud, to Azure. Or I can have my file share there, and it will keep all the files that are commonly accessed local, actually keep everything local until it runs out of space. But then when it runs out of space, it basically keeps the stuff back in Azure that it can't fit on its local drives. It keeps the local stuff, whatever you use commonly, and then things that are cold, that are not used very often, only up in Azure. So this is a nice appliance to help you use this type of scenario to do things where you have no servers locally, or where you have no full environment locally. But certain things like if I'm going to share around gigabyte VHD files, you might want some local storage, and this is something that helps enable that kind of a workload. Or if the office is really large and there's hundreds of users, you want to take that load off the WAN network if we can, and so that way they use it local, and we can even set criteria of when it's going to sync those changes up in that environment back up to the Azure. So Store Simple is certainly a nice tool for managing things in the cloud and with Azure storage that we don't have. Other things we built right directly into SQL is the ability to back up to Azure storage. We've also built into our Data Protection Manager product the ability to make a copy of the backup right into Azure storage. We also have Windows Azure Online Backup, which is a new tool we built into Azure. It's in preview still, and while it's in preview, it's a discounted price, but it's an agent that you basically install on your server, and it backs up your Windows servers to Azure, and it can do incremental backups to lower that bandwidth, reducing bandwidth of what you need to do a backup. So that goes out of technical preview sometime this fall's December timeframe. If we look at what's supported for backup with the Azure backup, it's basically all locally attached volumes. So anything that's a local disk. The other thing that read-only volumes don't work. It needs to do basically the volume shadow copies to get the differences and changes. So we have Windows Azure Backup. And Dan, I know you're a fan of Windows Azure Backup. Did you want to talk through this, or do you want me to?
Sure, yeah, happy to. So the Windows Azure Backup, and I've got a very detailed step-by-step blog post on how to configure this, as well as how to do the restore, how to set up the certificates, including a PowerShell script to actually go ahead and create the certificates for you and upload it. But basically what you're going to do is you're going to go in and sign up for the Windows Azure Backup. So you're enabling that service on your Windows Azure account. And then from there you install an agent onto the server that you want to protect, the server that you're backing up. That agent actually integrates with Windows Server. So it uses the backup technology built into that. You're basically registering that certificate on Windows Azure, which is going to give the agent capability to connect to your Windows Azure Backup. And at the same time, it's going to set the policy for Windows Azure and that agent. So that's all configured on the agent on the server that you're actually backing up. And then, of course, you can back up the agent will send the data over to the backup vault, which the backup vault is a piece that you've created inside of Windows Azure. You set the recovery date, time. Whenever you recover the data, if in fact you need to recover the data, then you're managing all of that from the client, and you can recover to the same server, or you can recover to a different server if that would be if that's needed. So basically, in order to do that, all you need to do is install the agent. Of course, you have to have the certificate on that agent as well, and then you can recover to that alternate server for full redundancy, not only for the data but also for the server itself. So restoring is as simple as dumping an OS on the machine, installing the agent, installing their certificate, and restore. And again, like Brian talked about earlier, in terms of pricing, the whole backup scenario is all free from a network bandwidth standpoint, and all you're really paying for is the storage, which, as we've talked about many times, is insanely inexpensive.
Thanks, Dan. Yeah, one of the things I didn't mention before when I was talking about the storage was the maximum amount of storage you have in an account. And so for each Microsoft account that you use, an account has a limit of 2 petabytes of storage. And so as long as your server isn't over 2 petabyte, you'll be able to back it up to your Azure storage accounts. But it's 2 petabytes of storage is kind of a bit, so I think we're pretty good. We already did this demo with showing the access from Cloudberry Explorer, which is a third-party tool. That was a free download for Cloudberry Explorer. They have other agents for backup that do cost money. So that's what we had for Azure Storage here. And so now we're ready to move on into the lab section of the day. So hopefully you guys are all signed up with a Microsoft ID already and signed up and enabled that ID for Azure. So you got your free copy of Azure.
Hey, Brian, before we cut out into the labs, let me just have the floor just for a second. I want to have a short shout out for Keith Mayer and Tommy Patterson, who are kind of handling the Q&A for us, and I really appreciate you guys stepping up and being able to help us with the many people that are online and viewing this presentation. I'll also notice that it looks like it was a unanimous on the either you very strongly agreed that this was a good event, or strongly agreed that or agreed that it was a good event. So everybody liked the event. That's great. Love the feedback. If you do have any suggestions on how we can make it even better, please go ahead and provide that into the chat window, as we will be doing additional events on Windows Azure probably, as well as some other topics. And if you have other topic ideas, you can certainly shoot those to us. Just a reminder, you can reach out to Brian and I via our blogs or via Twitter, and we're happy to take any feedback or suggestions that you might have on that.